So I'm going to play around with symbolic, what's it called it? Symbolic algebra. So MATLAB has this pretty cool symbolic toolbox, and with some of the newer versions of MATLAB, you can actually do some different kinds of things with it. So this is what I'm going to do. So instead of doing this work in a script, which is what I usually use, I'm going to do a new live script. So if you don't have that, it's okay. It'll still work. So basically the difference is, and let me just show you right quick. So if I'm just in a regular script and I say, oh, okay, so I've got, we're going to do this like x, and then I'm going to say like whatever is equal to x squared, and I run that in the command window, it's going to yell at me because, of course it is. Why are you yelling at me? Oh, because that. There we go. So I've got whatever is equal to x squared. But if I actually come in here and I create a new live script, and I take the exact same code and I put it over here, and then I go to my live editor and I run it, it's actually going to show up over here in pretty print. So everything that I'm going to do in the live editor, you can actually do regular, except when you do it regular, it's kind of like ugly, I guess. And then when you do it over here, it's like extra pretty. Okay, so I don't actually want to do that, so I'm going to close everything. And oops, I can't spell. All right, so let's see. So I'm going to start with a new live script, and I kind of have my notes over here that I'm going to play with. So basically the idea is that, as you kind of got an idea of, MATLAB can do symbolic algebra manipulation, which is pretty amazing because like that's just not something that like your regular calculator can do. And so let's just kind of play with it. So like, let's just say I want to start with like, I don't know, okay, so where I want to say with this, if I start with like this, like you saw me do a second ago, where syms x, I'm going to CLC clear, of course, because that's just how I like to start. So I'm going to declare that x is going to be symbolic. And then that means that I can say like x plus x plus x plus x or whatever. And whenever I run this, I'm going to be running sections. So that's just Control Enter or just run section. And it's going to say for x. Okay, so as a reminder, if I tried to do y plus y plus y, it's going to be like, I don't know what y is. Or even if I said, well, y is 3, and then I did y plus y, it's going to come back as 12. So I could do that here. Y plus, I can't spell, plus y. See how it comes back as 12. That's because y is, if you look over here in your workspace, y is, I need the class. Yeah. See how x is a symbol and y is a double. Now, just so you know, the symbols, not the size, bytes. Really? Okay, that's neat. It used to be that the symbols were a lot bigger, but it looks like they've pulled those sizes down. They've made some really neat upgrades to symbols since I started recording MATLAB videos, so that's kind of why we're doing this again. Okay, so basically the idea is the biggest difference between symbolic algebra and whatever you call it, regular MATLAB stuff, is you have to actually declare the variable as a symbolic variable. And so if you programmed in other languages, you're probably like, well, aren't you supposed to declare stuff anyway? Because most languages kind of make you. But MATLAB is kind of let you get away with not declaring stuff in advance. But for the purposes of doing stuff in symbolic, you have to call it. So here, it's even if I declare it, since I said y was equal to 3. So now if I do x and y, see 4x, 4y, yay! Okay, so let's see what else we're going to talk about. Okay, so you can go in and you can just kind of play around. I like to, put in e equals, mc squared. So I could declare emc, and I could say e is equal to mc squared. Now it reorganizes stuff just because that's what it likes to do. I don't know if it yells at me if you do that. Yeah, so see, you still have to put the times in there, just like you would normally with MATLAB. So mc squared, it still runs it through. Something kind of cool you can get is, let's see, how do I want to say this? So you can do stuff like this. So if I said times C, you see it's still going to come out with the same thing. So the neat thing about this is it always does symbolic manipulation, where it'll combine things. And so if I go plus C times M, it's going to arrange them in order of descending polynomial order. So if plus 3. So it's always going to put these. So even if I reorganize this, like this, I think it's still going to go over here. I'll do this plus again. And it reorganizes everything so it's in kind of that descending polynomial order that way. It's kind of what you would expect it to be, but it makes it pretty and it makes it easy to see. And that's one of the reasons that the live editor is kind of neat. All right, so take a sec and you can, let's do this here. So let's create symbolic expressions for these. Oh, I can't make that any bigger. Let's try and do it. Come here, girl. Shoops. It's gonna, there we go. Okay. So try and make like the two sides of the quadratic equation. Okay. So something that you're going to see is if I just do the double % here, it doesn't actually create a new section. That's not something that is recognized in the live script. So I actually need to put in a section break manually. I think this is the same thing you would do for section breaks in Word. We'll Control Enter. I'm not 100% sure. But anyway, I can put in a section break and that'll automatically put in that for me. So I like to start all my sections with a CLC clear, although sometimes it gets mad at me and tells me that that's not necessary, but it can just deal. So just to kind of practice with this, take a minute, pause the video, see if you can kind of put together the two sides of the quadratic equation and just kind of see what it looks like. It's kind of pretty. All right, so we're going to assume you did that. Now, if you just start and you go x1 is equal to negative b plus the square root, can't spell, of b squared minus 4ac, and we have to remember that all of this goes over to a. Oh, look, it even did a little thingy where, okay, this was cool. So I'm gonna start my open paren, and it closes my paren for me. Yay, woohoo! Okay, I'm just obviously blah, blah, blah. Okay, and I try to run this, and it's like, what are you talking about? So remember, I need to go ahead and declare my symbols, so A, B, and C. I don't think I need to declare x1 because basically once I set A, B, and C to all of this is obviously a symbol. So it's like, oh, okay, you can see by the little picture there that it knows that x1 is a symbol as well. But look, it's pretty. Wait, why is the negative? Oh, so well, it's pretty, but it's also dumb because, so it pulled out the negative and then it put a negative there, right? Because if I think about that algebraically, right? If that negative gets distributed, it'd be negative b plus the square root. So that's kind of annoying that it thinks it knows what I want, but you know, typical program, just making assumptions about my needs. And so I'm going to do the same thing again. I'm going to make a mistake on purpose though. So I'm going to go negative b, and this is going to be minus the square root of b squared minus 4ac over 2a. And now that's kind of neat also because of the pretty print over here, it lets you know that you definitely did something wrong. So I can look over here and go, wait a second, that doesn't look right. And there's a couple of things that I forgot to do. I forgot to put my 2a on the bottom altogether, but then I also forgot to put everything on the top in parentheses. And so that's kind of neat that I can go in here and I can play around and do that. And now it's negative b. This is, so it looks like it's backwards from the way I put it in, but this is actually correct again. It just does this weird thing with the negative sign. So that's fun. All right, let's see what else we're going to play with. Okay, so what's kind of neat is you can do expressions. See, it's actually running it for me. That's kind of neat. So as I'm scrolling here, it's kind of like whatever you call it, spoiler alert going on here. So let's see. I'm going to put in a new section break, and I'm going to type in this code. So I'm going to declare my symbols. So see, I can go in here, and I can say, all right, well, like we already said, this kind of simplifies. Let's take that one. I don't care that much. But if you look here, right, x plus 1, quantity squared, and then x squared plus 2x plus 1. So the question is, does this come out to be equal? And this is going to say no. And the reason it's saying no is because they're not expressed the same way. So this is something you want to be careful about if you're ever in a situation where you're trying to do equality of symbols, of symbolic algebra. It's a little tricky. So the way that you can get around this, I believe, is if you simplify both sides and then you run it, then it's like, oh, okay. So essentially just kind of introducing you to the concept of simplify. So if I simplify y1 and I'm going to simplify y2, and so you can see that whenever it's simplified, it actually contracts or factors the expression. So this y1, the way I had it, is the simplified version that MATLAB likes to see it in, and it's going to automatically take stuff and factor it. And so simplify is a nice little thing that you can use to show things that are, I mean, you wouldn't explicitly use it for equality. It's just mostly that I wanted to show you that, you know, MATLAB has the ability to do that. So you can do some weird things. You can be like, okay, so x plus x squared plus 2x plus 2, and I run it like that, and then I say, well, can that do anything? And it's like, no. I'm like, oh, okay, well, that's unfortunate because I kind of thought that it would. Well, I guess that does factor. It's just not factoring it the way I want it. I mean, it's factoring it, but it's not factoring it. It's factorable, but it's not factoring it. So to truly factor something, there actually is a factor function that it's going to throw these out. And I don't know what happened to those inner parentheses, but, you know. Oh. So obviously they've got some issues that they're still trying to sort out. Because like I said, it's not super new, but it's not fantastic. So we're obviously missing some stuff here. Just to kind of give you an idea of what this looks like here, I'm just going to take this and run this here. So see, it does give me the two factors, the x plus 2 and the x plus 1. So it's giving me those here. So I guess it's the same thing. It's just showing it better over here on the left. So maybe, let's try this. Let's take this whole thing. And then we're going to multiply it by x plus 3. Yeah, see, it's just listing the factors, but it's not actually doing anything fun with them. Let's see what happens whenever we say factor y1. So it actually lists both of the factors. So I guess maybe I'm just being obnoxious by insisting that there's parentheses there. So it's not actually showing what it looks like. So it's a little weird because you're like, that doesn't make sense. You're missing parentheses. But no, it turns out we're not missing parentheses. It's just specifically listing, it's just listing them like a matrix. Like, here are my two factors listed in a matrix. And it's like, I don't really like that. But, you know, I don't feel like doing all of this in my head and going from there. Okay, so now the next thing that's kind of fun is to look at actual equations, okay? So I'm going to put in another section break, and I'm going to declare E, M, and C, and I'm going to say now some new equation. So before, what I was doing, so this is important, I was doing E equals MC squared. So that's one way to do it. But another way to do it is to say that E is equal to MC squared is an equation that I care about. Now, see, it's doing this dumb thing because I already told it what E was. But if I come in here and I do it like this, so I cleared out that E, look, E is equal to MC squared. Okay, so this is an equation. And the reason I like these equations now is I can actually solve for different things within that equation. So if I say, here's my equation blah, and I want to solve for C. There we go. So I actually have two different solutions, right? Because you have the plus or minus the square root. So there's the square root on the positive square root and the negative square root. I can also solve for m. And it's e over c squared. So being able to solve for stuff is actually pretty cool. And I really like it a lot better here because, again, when you run it down here in the command window, it was a lot harder to see. So, I mean, you can still see it. There's e to the 1/2, or the square root of e over the square root of m, and then minus square root of e over square root of m. But this is a lot more clear, I guess, to your brain to be like what's actually going on. And this pretty print becomes really important whenever we're actually dealing with symbolic manipulation. So you can do some pretty cool stuff like that. So I liked that. So that's something that we can use or come back to. Let's see, what else can we do? So I talked about simplify. So let's do a new section. That was not the new section. What was it supposed to be? Control, Alt, Enter. Here we go. Okay, so X. So if I have this and I run this here, when you look at this, hopefully without too much effort, it's a little bit harder to see here, but it's pretty-ish clear here that the thing on the bottom is basically just this factor out thingy on the top. So we talked about using factor, so I could factor y, and it comes right back as 2. It actually would give me the same thing when I was trying to do something else, but I can simplify y, and it's also going to come back as 2. So it's basically going to, I was hoping that when I hit factor, it would actually factor out the top and the bottom, but it did that, and then it also deleted the common term, so that was a little disappointing. So let's do... Yeah, I'll just leave it, not worry about it. But anyway, you've got this ability now to simplify the algebraic manipulation, so it gets rid of it. Now, the one thing that it's not going to do, and if you're like super hardcore college algebra nerd, you're going to be like, well, technically x minus 3 or x equals -3 can't be a solution because, well, can it? No, x equals -3. No, because if you put x equals -3, then the bottom becomes 0. So theoretically, this should say x equals, or y equals 2, but x is not equal to -3. And that was a thing that you did at one point in college algebra, is if you factored something out of the top and the bottom, you had to make sure that you excluded from the final solution the places where x is blah, 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 blah. So actually, if you plotted y, oh, it's not going to let me do that. I don't think it's going to let me do that. No. One, let's do it this way. 1 to, let's go 2 to 4, 1,000 of those, and then y2 is going to be equal to this thing. I don't know if it's actually going to show up, but it might. No, it's not going to show up because it's not. But it was a good try. I don't know what I'm trying to do. I was kind of hoping to show you that it's not going to work. Plot. Yeah, I think it's going to yell at me. Plot. Blah, y2. I think it's just going to draw right through it. Let's see. Are you going to plot for me, sweetheart? Maybe, maybe not. Oh, well. I could show you on my T89. That might work. I don't know why I'm going into this. I just think it's kind of neat. I know why I'm doing it. So the reason I'm doing it is basically to show you that even when you're using a calculator is, you still have to have your brain on. It's the same thing as whenever you're using MATLAB, I guess. You can't just put stuff in and be like, there's the answer, and be like super happy and all. Because now if I graph this, in theory, if my calculator's being nice to me today, it's going to have a hole somewhere. Come here, girl. Come here. That's right. Come on, come on. Choo-ka-choo-ka-choo. All right, we're going to zoom. Let's do our window, actually. Oops. What do we decide from 2 to... and the y is from 1 to 3. Okay, let's try this again. So there should be a hole, and it doesn't see it either. So see, we're smarter than this stupid calculator. I got really excited. I thought that maybe my T89 can handle it, but no. All right, so all this to say, this was a waste of time. All this to say that whenever you're doing this, you want to just keep your brain on and know that, you know, you still have some certain things that aren't going to work. Okay. So we talked about comparing the equations. There's a couple of more functions that you can look at. Let's do this last bit. All right, so we have expand, we have factor, Numden, collect, simplify. So I again recommend that you pause the video, kind of play around with these and see, see what you can come up with. Okay, so again, let's just kind of pretend that you've done that. So let's just try play around. So let's just say I've got y is equal to x plus 3 quantity squared. And let's say I want to expand y. So it kind of does what you expect it would do, is it multiplies everything out. If I multiply by something else, it's going to do the same. It's basically going to just multiply everything out for you. So expand does kind of what you would think it would do, and I should pull up my T89 again, but the T89 has a lot of the similar ways of doing stuff, I guess. And again, if you do this down here, you're going to get the same thing. It's just going to not look as pretty. But this will let me be lazy, and all right, so then I can say now I want to factor that thing that I just unfactored, or that I just expanded, and it'll give me the 3 factors. So again, it's not that it's factoring it in the traditional way that we would think about it in this, where it says y equals, it's just getting me the 3 factors. Okay, now something right quick to remember, factor does something else, okay? So if you remember, if I ask you to factor 24, it's going to come out with the factors of 24. So factor is a function that works for symbolic data types and numeric data types. That's what's called an overloaded function, where it can do multiple things depending on the kind of input that you've given to it. So that's something to be aware of. So Numden, I think, let's check it out. Remember, we can always go help to get, I can't spell, to get information. So it's going to pull the numerator and the denominator out. So let's actually do up here where we have our quadratic equation just for funsies. So let's see. All right. So let's say that I want the Numden of x1. Now, notice that we actually have 2 outputs on the numerator and the denominator. Whatever I'm going to call it, blah 1 and blah 2 is Numden of x1. So see, it's going to come out with the numerator on the top and the denominator on the bottom. And now look what's funny is, remember that x1 did the thing where it pulled the negative out and it was like negative b plus the square root of b squared. Well, now it put it back in, so it left that negative back on the top, and it just put it in a weird order that kind of, I don't know about you, but seeing the quadratic equation in that order kind of freaks me out. Let's see what happens if I just do it as this thing, Numden x1, and just see what kind of output we get differently. So if I just ask for one output, it's only going to give me the numerator. So this is kind of like, what do you call it? The max function, where if you ask for 2 things, it gives you 2 things, or mesh grid, where you really, in mesh grid, you really need both of the outputs. So if you use Numden on a function or on an expression, you just get the num, unless you specifically ask for the num and the den. Okay, so collect, if I'm not mistaken, let's check it out. So help, collect, I can't spell. Okay, so collect basically combines things based on a specific set of terms. So if I have x1 and I want to collect it on the, I don't know if that's going to do anything interesting. Okay, yeah, it did. So basically what you're saying is I want you to rewrite this thing. Let me hide these because they're kind of getting in the way. Okay, so I want you to rewrite this, but I want you to put all the B's together. So basically it's collecting all the B terms, and then this is all the other stuff that it can't pull out. Let's see if we can make that a little bit more obvious. Okay, so hello is going to be X. Do I have X's and Y's? There's a Y, so I can just keep using that one. X times Y. Let's see what that does. Oh, because it's not going to be Y plus 3. I'm going to expand it. All right. Oh, except Y got overwritten. So, yeah, all right. Syms Z. Let's just do something crazy here. So I'm going to do okay. Z plus 6. Okay, there. How about that? Is that sufficiently obnoxious to make us happy? Well, it's sufficiently obnoxious to make me happy. Okay, so now what I can do is I'm going to collect the terms. For hello, I want to collect the Z terms together to see what that looks like. So see, now it's combining all the Z terms together. There's only just the one Z. Or not, I mean, there's only a Z to the first. So it combines the Z to the first. That's the coefficient on Z to the first. And this is the coefficient on nothing. And eventually, if you ever do partial fraction decomposition, although you would just do that symbolically if you had this open, that's something we kind of do sometimes. If I want to collect hello on X, come here. It's going to combine, here's the x cubed term, here's the x squared term, here's the x term, and then here's the constant term. So that is definitely something that I can see being valuable when you're doing symbolic manipulation to play around with this. Simplify does exactly what we said it does. I don't think that this is going to simplify at all. Oh, yeah, okay, so to simplify it, it went back to the original way of how I got it out, where it pulled out the z plus x. So that's pretty cool. Let's see if there's anything else that we absolutely have to talk about right now. Expand, factor, collect, simplify. Okay, very, very, very good. Oh, okay, this is just silly. Poly to sim. I'll just show you that right quick. If you have a bunch of coefficients, let's put in our new section. If I just have a like coefficients like 3, 2, and 1, and I do poly to sim, it's going to turn those coefficients into a not a polygon, a polynomial. So it's some kind of a weird little thing that I don't know if you'd ever really need it. If you wanted to make it in terms of like z, it's going to do everything by x in terms of x kind of naturally. But if you say z, it'll make it in terms of z. So again, not a super useful thing, but just kind of a weird little thing to play with. So I think this is a super long video, and I'll make another one to do a little bit more fun with symbolic algebra. But hopefully this is enough to kind of get you excited about this this little feature that we got.